The second video is about the area of rhombus or kites. That should be no. Okay. So a rhombus. We know this from previous lessons that a rhombus has 4 congruent sides, okay? We also know that the diagonals are perpendicular to us, which might become helpful in a lot of these problems because then if it's perpendicular, then we have a right triangle that could help us find missing measures. A kite has 2 pairs of consecutive congruent sides. So there's one pair that's consecutive, and there's the other pair that are consecutive. And you'll see that I didn't put the same number of congruent marks on there because the ones with the 2 marks are congruent, the one with the 1 marks are congruent. These diagonals are also perpendicular, and which then gives me a 90-degree triangle, which would help us find missing measures in problems if necessary. So the formula for the area of a rhombus or a kite is this right here, 1/2 times the length of diagonal 1 times the length of diagonal 2. So that's what those D1s mean. So the diagonal length. Okay. So again, I'm going to rewrite this in a form that I like to use. So area is equal to diagonal 1 times diagonal 2 all over 2. So divided by 2. So when I divide by 2 is the same thing as multiplying by 1/2. I just prefer this form, but it doesn't matter to me which one you use. Let's look at this first example. Find the area of the kite. So when I see these values, this is the length of the diagonal right here. Okay, diagonal 1, diagonal 2. And if I bring this down, I can see that that's the length of this diagonal right here. Okay, change my color. If I bring this across, I can see that that's these lengths right here. They are perpendicular to each other. So we know they're not the slanted distances, they are the lengths of those diagonals. So our formula, area is equal to diagonal 1 times diagonal 2, all divided by 2. So if I'm plugging what I know, the diagonal 1 is 7, diagonal 2 is 12, all divided by 2. So that is 84 divided by 2, and 84 divided by 2 is 42. So the area of this kite is 42, and then my units are feet. So 42 feet squared. Let's look at this example, which is the area of a rhombus. So we know that it's a rhombus because actually the rhombus, the diagonals aren't congruent. They're only congruent when you have a rectangle, but it is showing us that they bisect each other. So these 2 sides are congruent, and then these 2 sides are congruent. So since I'm given this length right here is 7, then I know the other side must also be 7. If I know that this length right here is 9, then I know that this length over here is also 9. So we have to be careful when we're working with these problems because we're given 7 and 9, but it's not the whole distance. So just be really careful about that. So if I pull this out here and I pull this out here, then I know the distance from there to there. So that length of that diagonal is 9 plus 9, which is 18. And then I can do the same thing with my other diagonal, and that distance right there, 7 plus 7 is 14. So my diagonals are those distances, 9 and 14, when it kind of looked like it might have been 14 and 18, which kind of looked like it might have been 9 and 7 to begin with, but knowing that that diagonal, this right here is the midpoint of both diagonals. So now we can use our formula for area of a rhombus. Area is equal to diagonal 1, diagonal 2, all divided by 2. We can plug in what we know. So 14 times 18, all divided by 2. You should be doing this work on your calculator as well. Make sure you're getting the right answers, not just writing down the numbers. So 14 times 18 is 252 divided by 2. And we get 126. And our units are inches, so inches squared. Now let's look at one more example. One diagonal of a rhombus is half as long as the other diagonal. If the area of the rhombus is 65 inches, what are the lengths of the diagonals? So this right here is the important part. Okay, so we have RT and we have US. Those are our diagonals. Okay, so diagonal 1 and diagonal 2. So we're being told that one diagonal is half the length of the other. So if we call RT X, then I hope you would agree with me that if US, so if one diagonal is half the length of the other, if I called US 2X, I know that this looks like I wrote it as one diagonal is twice the length of the other, but isn't that related to half? Isn't this right here 1/2 of 2x? Okay, so I could use the halves and I could say, okay, diagonal 1, so this is or RT in US. If I called this one X, then this one would have to be 1/2 X. So I hope you see, and then I hope you see that if I did this one and I took 2 times 1/2 X, I would be getting the same value. So either way is okay. I prefer thinking about it this way. And the same thing is if I had 1/3 X, I could use, or 1/3 the length, I could use X and I could use 3X because this right here is
That's okay.
That this right here would be 1/3 of 3X. So area is equal to diameter 1, diagonals. Area is equal to diagonal 1 is X, diagonal 2 is 2X. And then I'm just solving for X. X times X is X squared. So that's X times X squared. Oops, I forgot to put in my A. 65. And 65. So kind of lucky here that my 2's would cross out. So now I have 65 is equal to X squared. Well, how do I get rid of an X squared? I square root it. Let's look at one last example dealing with rhombuses. So you have, this question is saying you have one diagonal of a rhombus is half as long as the other diagonal. If the area of the rhombus is 65 inches squared, what are the lengths of the diagonals? So our goal here is that we want to find the length of the diagonals. Okay, so let's look at our two diagonals. We have US and we have RT. I'm going to call RT D1 and US D2. Okay. So one diagonal of a rhombus is half as long as the other diagonal. So if I call the short one x, okay, so when we don't know what something is, we call it x, then instead of using a half, I could use 2x. Would you agree with me that RT being x and US being 2x, that RT is 1/2 of 2x? Doesn't that work? Okay, so I like to use it that way rather than thinking about fractions. Or we could look at it this way, that RT in US, we call USX, then RT is 1/2 of x. And if we think about it this way, if I did 2 times 1/2, wouldn't I get x? So thinking about that mathematical reasoning and those connections between those fractions, I personally like to use this, okay? And you can do the same thing, that if it's a third, I could call one x and the other one 3x, because x is 1/3 of the other diagonal. I need 3 of them to get 3x. So just kind of using that and being able to be fluid with that math reasoning. So, and I paused the video, you guys, and I'm not really sure where I paused it by accident. So I might be repeating myself right here, but so I get 130 is equal to 2 times x is x squared. And then if I divide both sides by 2, I end up with x squared is equal to 65. So then how do we get rid of a square root? Well, I can square root both sides, and I get x is equal to the square root of 65. So I know the square root of 65 can't be simplified. So d1 is the square root of 65, and that makes d2 2 times 60, the square root of 65. And if I get decimal approximations, I end up with the square root of 65, which is 8.062. And if I do 2 times the square root of 65, I get 16.125 if I round appropriately. So this D1 is 1/2 of D2. And these are the lengths of my diagonals.